How you doing? My name is Moran and I work for Acbeyond. We are still going to do the electrical videos, so let's get to it right now. Where I left off before, I had the low switch and the high pressure switch on the wiring diagram, the schematic. So we're going to start as follows again. We're going to have, if you remember, we have the step-down transformer. Okay, this is going to be R and common, and we're going to have R, Y1, and G, and common. Okay, if you remember, we're talking about common. And G, we also had the G, we have the coil. We have here, so we have the, this is the coil, this is going to be, I'll put EC, and this will be EC1, and then we're going to have, then this is a three-phase, 1, 2, 3, okay? This is EC1, EC2, EC3. Now remember, this is the coil, EC, you're going to have to look for the numbers 1, 2, 3. That means when the coil energizes, the contact will close. Okay? And this is your E, which on your legend here before, you have the legend, you have EC, you will be your evaporator, contactor, okay? And then you have your E, here's your evaporator. Okay, so evaporator. Okay, now Y1. Y1 we had low pressure. High pressure and the coil. Okay, this will be your L, P, HP, and your CC. Your CC will be your compressor, contactor, LP, low pressure switch, HP, high pressure switch. Okay. Now we have the compressor is here. And then of course is three-phase, and this is your, well, getting fit over here, but it's okay. We have a C is your compressor, okay? And this is your legend here, okay? Okay, so now, like I was talking before, we have CC, CC1, CC2, CC3. Now over here we have the stat. If you can remember here, R, Y, G, and common. Now you have common here, we have G here, Y1 here, and then you have the R. Okay, stat. This is your terminal strip. Okay. Now, we know that when you're calling for cooling, okay, just say here, calling for cooling, power will go through here, low pressure switch is closed, high pressure switch is closed, the compressor contactor coil closes, pulls in, compressor comes on, and also the evaporator. Okay, that's it. Now we're going to put a safety on it. We're going to put a safety, it's called the, we're going to go with a lockout relay. Okay, now we're going to put the lockout relay, hold on, give me a second. Oh, like I was saying before, I'm going to use this, it's a relay, but we call it a lockout relay. It's a little dirty, it's old, but I don't know if you can see it, just a relay with points on it. And the way this relay is as follows. This is 4, 5, 1, and 3. Okay, now we're going to put the lockout relay in between before the low pressure switch, and I'm going to put it like one here, and then the other one is going to go fit over here like so. Okay, now if you look at the numbers, it's going to be 4 right here, 5, this is 1, and this is 3. Pretty much most of the coils are standard, 1 and 3 usually the coil, and 4 and 5 on this one also same thing, they're usually closed, they normally close. Okay, you also have over here 4 and 2 but we open, but we're not going to use that. Okay, the way it works is this: when 24 volts, you call for cooling, 24 volts goes like this way, right? And then voltage will go through here. Once it goes through here, this is closed, okay? So the voltage is going to go this way. Going to go, low pressure switch is closed, high pressure switch is closed, compressor comes on, okay? Now we notice that the voltage here also splits and goes through here, okay? Now if you notice between 4 and 1, it's like so, okay? So if you see that, what was this thing anyway, okay. If you notice the coil here, it could also energize because you're getting 24 volts. There's 24 volts here and 24 volts here. But what happens to electricity is the path of least resistance. Okay? When I was in school and everybody says, oh, the path of least resistance, but what they actually mean, okay? What that means is that, let's suppose that, I'll make it easier, okay. Let's say there's 2 guys over here. Okay, I don't know how to explain more easier for you, but, and there's a race, okay? And this is the finish line, okay? Right, so this guy he's going to start running, and you're going to keep going, okay? Same time as this guy right here. But over here, let's suppose that either there's a lake or could be a rock, a mountain. So what's going to happen is this guy's going to go through here, you got to swim. By the time he swims, this guy's already went first. So this guy won, right? So this is what is called the least resistance, meaning there's no resistance, there's no obstacle. It could go straight through, okay? This is the resistance. And when they say electricity is the path of least resistance, what it's trying to say is there's no resistance at all. So the path is going to be straight through. There should be no problem. And over here, you're going to get stuck. It could be like, that's an obstacle, that's resistance, okay? When it says path of least resistance, that means there's no resistance. So that's going to go first. So it's going to happen over here. This is path of least resistance. This right here is resistance. So you're going to stay here. Voltage is not going to go through here because the voltage already went this way. Okay? So by the time all the way goes around, this is 24 volts. 24 volts and this 24 volts. Okay? So what's going to happen? This here is going to be just resistance, but it's not going to do anything because you're going to be 24 volts going through. Remember, if this here would have been here, that's a different story. Because that's going to go straight to common, and that's going to energize the coil. But that's not going to happen. What's going to happen is here. Okay. So everything's going to be running up and running normal. What's going to happen is this does not get energized. So maybe if this one doesn't get energized, the coil, the contacts are not going to open. Meaning they're not going to open. Okay. So, okay, pretty much this will be technically like this. Okay, so we're looking at it like that. Okay, 24 volts and that's it. Okay, so what's going to happen is, if this unit, let's suppose, right now, we didn't put what kind of unit it is. Could be a water cooled, could be air cooled, because there's no condenser here. So pretty much I will tell it it's a water cooled unit. Okay, but if you put in the condenser, well, same thing. What I'm trying to say is that, let's say if we lose pressure, we lose low pressure or high head pressure, what's going to happen, one of these, let's suppose head pressure, it's going to open up. Okay, so if this opens up, okay, that opens, right here. Okay, once that opens, 24 volts is not going to longer is going to go here, it's going to stop right here. So instead of stop over here, remember the 24 volts was here hanging out? Then this was going to energize. This here, all the way this, in the coil, it's a common. This becomes common, and then just this coil opens up here. Okay? And that's your lockout relay. Okay? Locks out the high pressure switch or the low pressure switch. Okay? Like over, same thing over here. If we're looking at the voltage here, 24 volts goes here. But something, well, actually, you know what? It's going to be, something opens over here. Let's just suppose here. Okay? Put one and then we have the other one here. But anyway. So once this opens up, this opens, voltage is not going to go over here, voltage stops over here. And since you have voltage hanging over here and waiting, because all of this was 24 volts, this coil gets energized, this becomes common, goes to common, because remember, this here goes to common, and right here, common. So this to the transformer. So this energizes, opens this up, and now this coil and this coil, they're not the same size. See, this one has more ohms on it. Okay, this one has like about 97 ohms, and this one has like about 17 ohms. Okay, so since this is smaller, the 24 volts is going to get consumed all over here, and this is going to become common. Because if we would have two contactors or two coils same size, it's going to be chattering, which I have done it before, because we're trying, you know, my friends and I were trying to see what's going to happen, and we were chattering because it was going up and down. Because this coil has more resistance than this one. That's one of the reasons that, well, besides that, then this one has more resistance, and it takes more time to go through voltage through it. It's okay. And then it's gonna, anyway, you understand what I'm trying to say. So, and to be, okay, since this happens, this has higher, what do you call it, ohms, PDs, is not going to be able to pull the contactor coil in, so that means the compressor is going to cut out, and it's going to shut off. Fan, if it's an oil, depending on the fan, evaporator could be an automatic. It will shut down too, but if the thermostat is on, the fan will stay on. Okay? This is it for now. This is your lockout relay. Watch the video a couple of times. This is very informational. I'm going to do it again, but keep in mind that the way the electricity flows. Okay? Thank you for everything. Don't forget to subscribe on YouTube, Instagram, and also on LinkedIn. I'm under Oscar Moran. Thank you and have a goodbye.